We have taken another example here where we are looking that there are two tasks G and H whose preceders are C and D for H, but for G it is C, D and E. That means for this example, as per our previous example, we have met two tasks at a single state. Here we can meet C and D at a single state, but where E cannot meet. So we have taken this type of examples that how to proceed using these problem. Now look at the Pert chart. Provided that the question is A and B has no preceders, that means A and B will execute from the starting state, and it has created two new states, that is 1 and 2. C's preceder is B, simply C will execute from B and has created a new state, that is D. D's preceder is A, that is D will execute from the state 1, and we have met D at the state 3 where C ends, because C and D both are someone's preceder. So we have met C and D at a single point, that is, or at a single state, that is 3. E has its preceder as A, that means E will execute from A and has created a new state, that is state 4. F's preceder is A, F will again execute from 1, and as F is none's preceder, that means A after executing from 1 has ended at state 5, which will be the end state. Clear? After F, G is the next task which will proceed or execute from the state where C, D and E simultaneously will end. Now we have created a state, that is state 3, where the tasks C and D has met, but G cannot execute from state 3 as G's preceder is C, D and E, but we have not joined E in the state 3 because there is another task H which will execute from state 3 where only C and D will meet. So we will have to join state 3 and 4 with a task. Now we cannot add any new task over the processes or the tasks that are already being created for the development of the project. So this task which will join 3 and 4 but is not mentioned in the process or sub-processes of the entire system will be denoted as phi task, whose duration is 0 unit. Okay, and this phi task is known as null task. Now we have joined this state 3 and 4 with a task which will have an execution state and an end state. We have to identify which will be the execution state and which will be the end state. Look, we have provided the arrow from 3 to 4 because 3, if we provide as the state 4 as the starting state and state 3 at the end state, that means if the arrow was in this side or to be provided in this side, that means any task which will execute from state 3 will have its preceders as C, D and E, but H is the task whose preceders are only C and D. That means H must have to execute from state 3 and will end or meet the end state as H is none's preceders. This is clear. That means we will have to take for the task G to provide the null task or phi task from 3 towards 4 as C and D ends at state 3, whose output or end product will be forwarded to state 4, where we will provide or we will get or the system will get the output of the task E, and taking the output of all the 3 tasks, G will execute and it will end at the end state, that is state 5.